Just attach some acetal on the bottom and I'm sure it'll slide like ice. Acetal. A-C-E-T-A-L. Acetal. Acetal is a common engineering material used for a whole bunch of stuff. One of the first exposures I had to acetal was when I was working as a biomedical engineer doing a lot of testing of devices. And another engineer explained it best to me that oftentimes we use the material acetal when we want some of the properties of aluminum, like a little bit of stiffness and a little bit of strength and the ability to easily carve it up or machine it. But then we also don't want other properties of aluminum. For example, we want less friction. You can't slide across aluminum very easily, but you can slide across acetal. Acetal also might be a little bit lighter, so maybe you don't want the weight of aluminum. Acetal is a polymer. It's a plastic. It goes by a whole bunch of names, brand names. In fact, I first really heard about it a lot as Delrin, but there's a whole bunch of other companies that make acetal. Acetal is a common name for the chemical name of polyoxymethylene. Polyoxymethylene. It sounds like that thing you yell out as a kid after you play hide and seek. Oxen free. And I think in the future it'd be nice if kids yelled out polyoxymethylene to say that you're ready to come out, but I digress. Polyoxymethylene, if you know your chemistry, suggests, the poly part is saying that it's a macromolecule. It's a whole bunch of atoms and molecules linked together. Oxygens and carbons and hydrogens all chained together in a certain configuration. And when you make this huge macromolecule all together in a certain way, that is acetal. So going back to the reasons why you might use acetal, it goes back down to those chemical properties. Maybe you want something that's a little bit more lightweight than a metal. Maybe you don't want to conduct electricity. Maybe you want a material that's not going to corrode or rust. These are all good reasons to maybe look at acetal instead of aluminum or something like that. Now, granted, as a biomedical engineer, we could not put acetal inside somebody. It's not an implant material for the most part because it can absorb liquids, and it just didn't have the ideal biocompatibility properties that you would want. However, you could use it outside the body. You could use it for maybe mechanical gears inside some of the tools that a surgeon might be using. You could use it as an insulator in other products outside of biomedical engineering entirely. It's a great little versatile material, which can be expensive if you get a lot of it. But hey, machinists like it, engineers like it. That's why acetal is our engineering word of the day. This is your host, Pius, saying once again, thank you for listening to the Engineering Word of the Day. If you like this kind of stuff, you should listen to the long-form podcast called the K-12 Engineering Education Podcast, where you can learn all sorts of engineering and education-related stuff. Go on over to k12engineering.net to learn more.